Hey everyone, you're watching the show where I solve the daily and I get it on one line. Let's see what we got today. Doesn't look too bad. Largest combination with bitwise and greater than 0. You can skip elements. If you couldn't skip elements, it would just be sliding window. Since you can, and I'm gonna go ahead and change this to A, you could take every element. You could say, okay, 16, there's only one bit in the 16's place. 17 is maybe a better example. You could AND everything with the 1 bit or AND everything with the 16's bit. Both of those will at least have the 17 in there. And then you check like which bit, if I only selected for this, would have the most numbers that have this bit. One way I could do that is roll through the array. Let's have the bit counter. So C equals 0 times 20. We don't really have to hash anything. For X in A, for bit in range 20, C plus equals bool, 1 to the bit and X. So it'll go through 1, 2, 4, 8, and so on. It's C at bit plus equals that. And then just return max C. All right, fine. Okay, so there's one solution. It's not particularly slow, I'll be honest. It's interesting to me that it is this slow, though. It doesn't seem on a different order of magnitude, so I'm guessing it's just like the fact that those earlier submissions had less test cases or something like that. So how do I get this on one line? Do I want to say return max of just an expression? That is one solution. Max of 1 to the bit and X for X in C for bit in range 32. But that's kind of weird that I'm going bit by bit. But if I go bit by bit, it allows me to, I don't have to like do any weird like in-place modification. I can just straight up say return max. Return max of map range 32. And then there's going to be lambda bit. Lord help me that I can get the bit out. And I'll say lambda b. Sum map something with the array. And what this is going to be, I want another map too, for the record. I want to AND the bit with the proper element in the array. So I think I can just say partial AND. I don't want to AND the bit. I want to AND 1 to the bit. Okay, there we go. Let's see how this does. Nice. So let's get this lambda out of here. I wonder if I can just go layer by layer. Like, what if I just said map of sum and all of this? What if I took the sum out and I added that to the next layer? Okay, that gets rid of that. I think I could do the same thing with map bool. No, that's okay. We want map, partial, map, and bool. Okay, we got rid of that. Ooh, this is gonna be ugly. Ooh, this is gonna be weird. It's gonna be partial, map, partial, and 1 to the b. I think. So this does work. Lambda b, map partial and 1 to the b to a. So a I can use. B, I have to find a way to express this as a function that operates on b. Okay, it's not gonna be that bad. I just have to like go by composition. So I'm going to say instead of range 32, I don't really want that. What I really want is map operator. What's like bit shift? A shifted left by B. So I want partial L shift 1. Okay, and then now I should be able to just say B. Map partial and B to A. Okay, a little closer. And now we want to create a partial with B to map to A. I don't know if that one's doable. That's pretty, no, I think it is doable. It's just really tricky. So I want to take this term again, map something else. And what that is going to be is it's going to create the correct partial function. Oh my God. Is this going to be a map partial, good Lord, with a partial and then B will be inserted as the input to this first partial that already had and inputted, which then is inputted into the second partial that is then partial and B. So I should be able to now say this is just B. Okay, and then map B to A is not that bad. That's just... If these were reversed, if it was map A to B, this would be a lot easier. If I call star map, call, zip, repeat B and A, this would do it, right? This is functionally the same thing. And from here, I don't think it's that hard. I think it's just going to be like long. So first thing to get out is to say, well, I guess I'm mapping a repeat to that. So now this is just zip B and A. And then the next thing is to say lambda B, zip B and A, which isn't great, right? That's kind of just getting us back to where we were, but it's not quite getting us back to where we were. Because now I could say, first off, let's get the zip out of there. So I'll say map partial zip and A. This is going to be A zipped with B because of the way partial works. A is going to be the first input, and then it's going to say, and now the second input is B. So then it's going to be backwards. So if right here I just said star map call to B, it's going to be like you can't call on a sequence or something like that. You can't call on an int. So I need to reverse it. So we want to reverse each thing in B, right? That works. Lambda B map reversed to B. How do you get rid of the lambda here? Man, this one's so confusing. I don't know how I'm able to do this when I'm this dissociative, because I'm not on my game right now. I think you could say map partial map and reversed to B. Okay, and then we no longer need map reversed to B. I should now just be able to say star map call and B. Oh, I did forget a comma. Okay, and now this is still like kind of complicated, but this part, this final part, is basically the exact same thing as what we just did. So it's going to be map partial star map call. No, I'm losing it. Map partial star map. That's the function we're inputting into the partial function. With call the function as the default input to star map, the input that gets submitted to the partial function that then outputs a function, which is a partial star map function, with a call function as the input. And I think if I'm getting rid of the lambda, I think it's just this. Wow. That's probably the most complicated one I've ever done. Like, I've done way more. I've done like Dijkstra's and stuff like that in this. I've done a lot of complicated stuff. But in terms of just raw logical confusingness, this is decidedly the most confusing thing I've ever created. Feels good. Feel proud. Thanks for watching.